In this video, I will explain each law of indices. I'll start off by explaining these four main rules. So the first one, a to the power of 1 is a. This means that anything to the power of 1 is itself. For example, 2 to the power of 1 is 2. Now on to the second one, a to the power of 0 is 1. This means that anything to the power of 0 is 1. For example, 2 to the power of 0 is 1. Raising a number to the power of 0 means we're not multiplying at all. We're starting, but we haven't done any multiplication yet. In math, when we don't apply any operation, like multiplying, we use 1 as the identity. It means nothing has changed yet. So to keep the math consistent and logical, any non-zero number raised to the power of 0 is defined as 1. Now on to the next one. A to the power of m times a to the power of n is a to the power of m plus n. Basically, if the indices have the same base, then they can be multiplied, therefore their powers would be added together. In this case, it would be 2 to the power of 5, which is 32. Now on to the next one. A to the power of m divided by a to the power of n. This means that if the indices have the same base, their powers can be subtracted from each other. So in this case, the answer would be 2 to the power of 1, which we know would be 2. Now on to the next three. So the first one. This means that to raise indices to have a new power, multiply their powers together to get the answer. For example, if we were to solve this, we would multiply 2 and 3 together since they are the powers. Therefore, the answer would be 2 to the power of 6. Just to be clear, this means that 2 to the power of 2, which is 4, is multiplied by itself 3 times to get the answer. 4 times 4 times 4 is 64, which would be equivalent to 2 to the power of 6. Now on to the second one. This means that to raise a product to a power, apply the power to both numbers and multiply. For example, 2x to the power of 2. Since we would multiply their powers to both numbers in the brackets, the answer would be 4x squared. Now on to the third one. This means that to raise a fraction to a power, apply the power to both the numerator and denominator. For example, 2 over 3 to the power of 2. Since we're multiplying the powers to both numerator and denominator, the answer would be 4 over 9. Now on to the next one. This means that a negative power is the reciprocal. For example, 2 to the power of negative 1 equals a half. Similar to this, a to the power of negative n, which could be any number, would equal 1 over a to the power n. For example, 2 to the power of negative 3 would equal 1 over 2 to the power of 3, which is 1 over 8. Now on to the next one. This means that a fraction to a negative power is the reciprocal of the fraction to the positive power. Now this is definitely easier once you see it, so I'll move on to solving a question. For example, 2 over 3 to the power of negative 2. We first want to get rid of the negative before the 2, so we would flip the numerator and denominator to make it 3 over 2, and then to the power of positive 2. And because we know the rule for this, we can solve this by multiplying the power 2 to both the numerator and denominator. Therefore, the answer would be 9 over 4. Now on to the next one. This means that a fractional power, 1 over n, is the nth root. For example, 4 to the power of a half. This means that we have to find the second root for root 4, which is basically root 4, which we know is 2. I will solve another example since this might be a little confusing. For example, 27 to the power of 1/3. Therefore, we have to find a third root of 27. Therefore, the answer would be 3. Now on to the next one. This one might be a little confusing, so I'll explain in detail. So first you would want to convert the power to 1 over n times negative 1. Next, you would want to convert the a to the power of 1 over n into roots, which is one of the indices rules we know. And lastly, the power negative 1 allows the whole thing to be converted to a fraction, therefore the answer is 1 over the root. So to put into words, this means that a negative fractional power is 1 over the root. And here's an example question. Try to solve it on your own and then check for the answer. If you got 1 over 3 root 5, then it's correct. Now finally onto the last one. This means that a fractional power m over n is the nth root at all to the power m. So this is a broken down version of how this rule works. So first you would want to split m over n into 1 over n times m. And then you can convert the a to the power of 1 over n into roots, which we learned towards the beginning of the video. Now you would want to multiply the power m to the number in the brackets, which would give you n root a to the power of m. And here's another example question. Try to solve it on your own and then check for the answer. If you got 3 root 5 to the power of 5, then it's correct.